find the domain and range of the following function, classify the surface, and sketch the graph. And here we have f of xy is equal to the square root of x squared plus y squared plus 9. So our domain, so looking at our given function here, since we have a square root, we know that our radicand must be positive. So we have x squared plus y squared plus 9 must be greater than or equal to 0. But noting here our two variables, x squared and y squared, are both raised to an even power. So we know regardless of if we're plugging in a negative or positive value, x squared is always positive and y squared is always positive. So we can note that our x squared plus y squared plus 9 is always positive. Woohoo! So we can say that therefore the domain of this function is the entirety of R2. So we're now ready to go ahead and find our range. So we want to note that even if we let x and y both be 0, that this x squared plus y squared plus 9 will always be greater than or equal to 9. So to attain our given function here, we can now go ahead and we'll take the square root of both sides of our inequality, which leave us with the square root of x squared plus y squared plus 9 is greater than or equal to 3. And we'll make a little love note here to ourselves that since z is equal to f of xy, this lets us know that z is greater than or equal to 3. And so this is our range. And we'll also be able to confirm our range when we go ahead and sketch our graph. So before we sketch, we want to classify the surface. So starting out with our given function here, we have that z is equal to the square root of x squared plus y squared plus 9. And we want to go ahead and remove the square root. So we'll go and square both sides of our equation, which leaves us with z squared is equal to x squared plus y squared plus 9. And bringing all of our variables to one side, we now have minus x squared minus y squared plus z squared is equal to 9, which is fine. We can leave it like this, or we can divide both sides of this equation by 9 to give us minus x squared over 9 minus y squared over 9 plus z squared over 9, which is equal to 1. And looking at this second form of our equation here, we recognize that it looks similar to the quadratic surface defined as minus x squared over a squared minus y squared over b squared plus z squared over c squared is equal to 1. And so since the coefficient of z is positive, we know that this is a hyperboloid of two sheets centered about the z-axis. We want to keep our range restriction in mind. So since z must be greater than or equal to 0, our surface f is the upper half of a hyperboloid of two sheets. Centered about the z-axis. Again, we can note here that since z is greater than or equal to 0, we also have a vertice at the ordered pair 0, 0, c, and our coefficient c here is 3. So we'll want to be sure to indicate this vertice on our graph. So we have our z-axis, our x-axis, and our y-axis. I will say here is our vertice on the z-axis at the ordered triplet 0, 0, 3. And then we have the upper half of a hyperboloid of 2 sheets. And we'll incorporate some trace ellipses here to appreciate our three-dimensional surface. And so this is our beautiful graph of the surface here defined by the square root of x squared plus y squared plus 9.